here we go, our Unit 10 three-dimensional geometry review. This is going off of your practice test, so you can follow along. All right, for the beginning part of your test, you're going to be asked to choose the correct name for each three-dimensional shape. You're going to have some that are in the shape of prisms, some that are in the shape of pyramids, and some that are in the other category. So we need to know, how do we know if it's a prism or a pyramid? Because I think that'll be the pyramid. I think that'll be the hardest thing to decipher from one to another. So we have to know that a prism is where we take a shape and it's like we stretched it out and we have the same shape on two ends. Okay, it could be the top end and the bottom end, the left side and the right side, the front and the back, but we have the same shape appearing twice, and it looks like that shape was stretched out so it's connected with rectangles. A pyramid is going to be made up of one shape on the bottom, and then on the other side, instead of having that same shape, there's going to be a single point. Okay, most of the time, it's going to kind of resemble those pyramids in Egypt. So we name a prism or a pyramid based on the shape of its base. Okay, so we're going to look at these examples and talk about how we name them. So on this first one over here, we've got a triangle in the front that's been stretched to this triangle on the back. Okay, so the base of this shape is a triangle. So we're going to call it a triangular prism. A prism because it was a shape that was stretched from the front to the back. The second one, again, we've got a trapezoid on the front and the same trapezoid on the back. It looks like this trapezoid just got pulled back this direction. Okay, so we're going to name it based on this shape. It's a trapezoidal prism. Okay, and so we are looking at the shape that is not rectangles. Now, if there's only rectangles in the shape, then it's probably a rectangular prism. But notice how both of these shapes had rectangles. See, there's a rectangle here. We aren't going to use the word rectangle unless it's the only shape that we see, because all prisms are going to have some rectangles in them, just like all pyramids are going to have triangles in them. Okay, so notice this is a pyramid down here, and notice you see a triangle. We have repeating triangles, but we want to look at the shape opposite of the point. So here's the point. The shape opposite of the point is going to be our base, and our base in this one happens to be a triangle. So we're going to call it a triangular pyramid. Okay, if I had a rectangle at the bottom and a point at the top, see how it's also made up of a bunch of triangles? But it's not a triangular pyramid. It's going to be whatever the base is. So the opposite of that point. And then over here, this is a sphere. I want you to memorize 3 of these, the circle ones. So a rounded circle, a three-dimensional circle is called a sphere. It looks like a ball. What would look like a pyramid made out of a circle is called a cone. Looks like a cone, doesn't it? And then lastly, if there's a circle on the top and a bottom that would look like a circle prism, it's called a cylinder. Now, we don't call these prisms or pyramids because circles aren't polygons, and so they're technically not polyhedrons, so they're not named with prism or pyramid. But these are the 3 that I want you to memorize that would not be considered a prism or a pyramid. Okay, next. Faces, edges, and vertices. Okay, if we are looking at the faces of a shape, we are looking at the sides of the shape. So all of these shapes that make it up. So see how the bottom here is a pentagon? Well, this is a pentagonal prism. So I've got the bottom and the top are pentagons, and then coming down from each side of the pentagon is another side. Do you see that? So around the edges I have 5 sides, and then I have a top and a bottom. So 5 plus the top plus the bottom, that's a total of 7 faces. Then for edges, I'm going to have all of these lines. Think of it as the place where 2 faces come together. Okay, so around the top I have 5 edges. On the bottom I have 5 more edges. And coming down from the top to the bottom, I have 5 more edges again. So I have a total of 15 edges. And lastly, vertices. A vertex is 1 point. Vertices are the plural form of points, or we can think of them as corners or angles in the shape. So I've got 1 corner, 2, 3, 4, 5, and then on the bottom, 1, 2, 3, 4, 5, for a total of 10 vertices. Okay, let's do the next ones, but this time I'm just going to try and do them pretty quickly here. So this next one is a cube. A cube, just like a dice, has 4 sides going around the edges, and we've got a top and we've got a bottom for a total of 6 faces. Then edges, we've got the 4 going around the top, the 4 going around the bottom, and the 4 connecting the top and the bottom. So 4 and 4 and 4 make 12 edges. And lastly, vertices, we've got all of these points in the top, that's 4, all of the points in the bottom, that's another 4, for a total of 8. Moving on to the rectangular pyramid, we've got a base that's a rectangle or possibly a square. And so think of it as I've got one side coming up from each one of the sides on the bottom. So I've got one in the back, one on the right, one in the front, one on the left. So I've got a total of 5 faces. Edges, I've got 1, 2, 3, 4 coming up from the 1, 2, 3, 4 sides. So I've got a total of 8 edges. And then vertices, I've got the 4 around the bottom, and they come up to just 1 point at the top. So I've got 5 vertices. Volume. Volume is where I'm taking the area of that base of the shape and I'm multiplying it by the other dimension. The other dimension, we're going to call it a height. Volume equals area of the base times the height. So area of the base is a big B, base. And that means that we are looking at what is the area that this shape takes up, just the area that it sits on. Okay, so if I take 3 times 4, I get 12. That's the area of the base. Then I'm going to multiply it times 5. Here's why. Think of the area of the base being what's the bottom layer, right? And then 3-dimensionally, the bottom layer would be 12 cubes. Technically, area isn't cubes, but there would be 12 here, correct? 3 going this way, 4 going this way. It's a rectangle. There's going to be 12 there. We could actually even count the top to find out what the area of one layer is. Okay, there's 12. And each one of these is going to hold 12. And that's why we're multiplying it. We're doing the quick math. Instead of adding 12 plus 12 plus 12 plus 12 plus 12, we're multiplying 12 times 5 to get 60 centimeters cubed. Now, you learned in elementary school to take length times width times height, and that's all great when you're doing a rectangular prism. The reason why we're changing this to the area of the base times the height, or the other dimension, is because next I'm going to show you triangular prisms, and then we're going to do trapezoidal prisms, and those don't work for length times width times height. You can manipulate length times width times height to make some of them work, but I think it's easier to think area of the base times that other dimension. Okay, so let's do the next one. Again, area of the base times the other dimension. So the area of the base, well, think about, I would name this based on its base shape. It's a prism, so I am going to call the triangle its base. So I want to find the area of that blue triangle that I just made. Area of a triangle is base times height divided by 2. Base times height is 12, divided by 2 is 6. So the area of this shape on the base is 6. Then, if this triangle is 6, let's make this triangle 3-dimensional. Let's make it made up of cubes. Okay, one layer is 6. So think about this. I'm making like strips of 6. Okay, how many am I going to do? I'm going to do 8 of them. I'm going to take that times the height. Now, 8, which is the height. So you might say, Miss Larson, this does not look like a height. Height is up and down, right? Well, technically, remember, we have to be flexible with these words. So if this is my base, this blue part is my base, we're thinking about how many of those would repeat as we went the other direction, because we want to fill it. So since this is one layer, let's fill it, do another layer, another layer, another layer, and that's how I get the 8. It wouldn't make sense to use this 5 because that's this distance. We didn't need that yet. Okay, 6 times 8 is 48 centimeters cubed, because volume is always cubed. The next one is a trapezoid. We learned when we were doing area of trapezoids that we have 2 trapezoids together. That's not exactly a perfect trapezoid, but 2 trapezoids together make a parallelogram. Okay, like this. That's my parallelogram. Okay, but notice how one is right side up and the other one's upside down. So we have the long end, 7, and the short end, 4, to make up this base of the trapezoid. And then the height is still 3. So if I wanted to find the area of this parallelogram that I made, the red shape that I made, I'm going to take the 7 plus the 4, that's 11, and multiply it times the 3. So I get a total of 33. Okay, but I want to know what's just the area of this one trapezoid. Okay, so the area of both trapezoids is 33. The area of one trapezoid is going to be 16.5, or in other words, half of that. So the area of the base, the area of this trapezoid, is 16.5. Okay, so that's my base. What's the other direction? The other direction is going to be this way, 13. So this we're going to call the height. So we're going to multiply that times 13. I'll grab my calculator. 16.5 times 13. 16.5 times 13, double check here, is 214.5 meters cubed. Okay, so what did we do on all 3 of these examples? We found the base. That was, for this one, it was a trapezoid. We found the area of that base, and then we found the other dimension that we didn't use yet, that's going the opposite way. We call that the height, and we multiply those together. When we're finding surface area, I'm going to ask you on your test to draw the shapes of all of the faces. So if I'm looking at this one, I know it's a rectangular prism. I know that this is going to have 6 faces. I'm going to have a top, a bottom, a left, a right, a front, and a back. So and they're all going to be rectangles, right? So we're going to call it top, bottom, front, back, left, right. Now you can actually make these look quite nice and perfect, but I'm doing this because we have already spent a lot of time on this video. I'm doing it quickly. So these 2 are together, right? We're going to call them the top and the bottom. Okay, if I'm calling it the top and the bottom, they're going to be a 3 by 4. So 3 by 4. How big is the area of the top and how big is the area of the bottom? They're both 3 times 4, which is 12. Okay, so totally together for my top and my bottom, I have 24 centimeters squared. Okay, put those together. So that covered my top and the bottom part. Okay, we're going to call the next one my left and my right. Okay, left and right. So I've got the left of the shape and the right of the shape you can't see, but they're going to match, right? So I've got 3 by 5. 3 by 5, 3 by 5. Okay, 3 times 5 is 15. So if the left is 15, the right is also 15, and together that's 30 centimeters squared for the left and the right. And then lastly, I've got the front, and I can't see it, but we know that there's also a back side, and that back side's going to match the front side. It's 4 by 5. Okay, so I've got my front, my front and my back is 4 by 5. 4 by 5. So I've got 4 times 5 is 20. The area is 20 on each, so I have a total of 40 centimeters squared. Okay, so if I want to add my top, bottom, left, right, front, and back, this is my top and bottom, left and right, front and back. Now, I didn't have to make these. I could have just added each one of these 6 all together at the end, but I added these already. So I've got 94 centimeters squared. This is area, so it's centimeters squared. So what I did do, I took 24 plus 30 plus 40, and that gave me 94. So you're going to have 2 of these to do. I want to see your shapes drawn out. That's actually a point on your test. And then show me the areas added up. So finding the correct surface area is a second point on your test. You'll have one that looks like a rectangular prism, and the other one's going to look like a triangular prism. So let's do this one. On this one, we've got our front and back, and they match, don't they? So my front and my back are triangles, and they're matching triangles. I'm going to call this front and back. I need a base and a height so that I can measure my triangle's area. A base of 3, a height of 4. Okay, so an area of, well, 3 times 4 divided by 2, I've got an area of 6 and an area of 6. Okay, then I'm going to do my sides. So let's start with this back side. Now, notice these are not going to match each other. So this looks like it's got a height of 4 and a length, well, it's not 5, a length of 8, right? So I've got a rectangle that's 4 by 8. And I'm just going to make it my blue rectangle because it's kind of hard to say, is that the back, the front, the left, the right. So 4 times 8, that's 32. That's the area of that one. Okay. Then I've got this one that's kind of, I don't know what to call it, on the right-hand side. And this one has this line we haven't used yet. This is 5, okay, by 8. So this rectangle is going to be 5 by 8 for a total of 40 centimeters squared. Okay, and then we have one more we haven't used, and that's this bottom part. And that is 3 by 8. Okay, so we've got a 3 by 8, 3 by 8. And 3 times 8 is 24. So the last thing that I do is I take my 6 plus my 6 plus my 32 plus my 40 plus my 24. Let's see, 70, 80, 96, 96, 108 centimeters squared. Okay, so the step-by-step process of surface area: draw out all of the faces using the dimensions, find the area of each one of those faces, and then add up all of those areas together. Your label will always be squared. Have a great time studying. Good luck on your test.